Students, this is Santoshi, lecturer in mechanical engineering, working in Jain Government Polytechnic College, Ramantapur. I am going to study for fifth. I am going to teach for fifth semester students. My subject name is refrigeration and air conditioning. In this subject, I am going to teach. Topic name is refrigerants and equipments. In this topic, the subtopic name is requirements of refrigerants. What are the requirements in the refrigerants? So we already discussed about the various types of compressors and various types of condensers and a comparison between water cooled and air cooled condensers. Okay, today we would be able to know about the what is evaporator and classification of evaporators and principle of various types of evaporators. Okay, what is evaporator? Is also known as a cooling coil or cooler or a freezer. So it is like a cooling coil, cooling purpose for cooling the cooler, like it acts as a cooler or a freezer where we keep all storage items like foodstuffs or medicines or whatever we need to store. Refrigeration effect or coldness is produced in the evaporator. It is located on the low pressure side of refrigerating system. The refrigerant from the expansion valve entered into the evaporator where the temperature is below the temperature required to be maintained in the refrigerated space. It extracts the heat from the refrigerated space and produces the coldness. So the temperature which entering into the evaporator, the temperature is lower than the inside temperature. So it absorbs the heat is how the heat is transferred. The heat is transferred from the high temperature to low temperature. So in the evaporator space, the high temperature, the inside which is entering into the evaporator, that is the low temperature. So heat transfer from the high temperature to low temperature. So heat transfer from the refrigerator space to the refrigerator space to the lower temperature, which is entering into the evaporator. So the low temperature extracts the heat from the evaporator or space and evaporator space and produces the coldness in the space. So this is about the evaporator and function of evaporator. Then classification of evaporators. According to the types of construction, there are bare tube coil evaporator and finned tube evaporator and plate evaporator, shell and tube evaporator, shell and coil evaporator, tube evaporator. So according to the manner which liquid refrigerants is fed, flooded evaporator, dry expansion evaporator, and according to the mode of heat transfer, natural convection evaporator and forced convection evaporator. Okay, according to the operations, frosting evaporator, non-frosting evaporator, defrosting evaporator, and according to the we are considering different conditions. Okay, first one, mode of heat so liquid refrigerant, by taking of the according to the liquid refrigerant, which are the refrigerant we are taking: flooded evaporator, dry expansion evaporator. So manner which liquid refrigerants we fed. So which liquid, based on the refrigerant, the evaporators are two types, and based on the mode of transfer of heat, one is natural convection heat evaporator and forced convection evaporator. So next one is the conditions, frosting condition, non-frosting and defrosting conditions, and based on first one is the flooded tube type evaporator. See the construction details of a flooded tube evaporator. Here the parts are, first one is a flash chamber and one pipeline from suction to compressor, suction to compressor, and here entry liquid from the receiver that receives the liquid from the receiver. There is a float controller is there, and one buffle is there, and a liquid level indicator of vapor and liquid that separates the float controller to separate the vapor and liquid. Next one is evaporator liquid vapor mixture. One coil is there. Okay, this is about the construction diagram of fluoride type evaporator. In the fluoride type evaporator, the first liquid liquid from the receiver is before receiver. The liquid receiver receives the liquid refrigerant from the condenser, condenser to receiver to, and then it's sent to the evaporator through the flash chamber. So the float control valve controls the entering of liquid refrigerant. So it flows as a flash chamber. Liquid refrigerant enter into the flash chamber to the as a liquid refrigerant. It comes here, and then it mixes. It forms as a liquid and vapor mixture, and then they send it to the form as heat absorbs extracts from the space. Then it converted into liquid refrigerant, and then liquid refrigerant is converted into vapor refrigerant. Why it is converted into vapor refrigerant? Because as in liquid refrigerant, the temperature is low. As it absorbs it extracts the heat from the space, or in evaporator, the temperature increases. So as the temperature increases, the state also changes. So liquid state to vapor state. So refrigerant, the liquid refrigerant converted into vapor refrigerant. So the vapor refrigerant send it to the compressor through the buffle. This is about the construction of a fluoride tube evaporator. Fluoride tube type evaporator. See, the fluoride type evaporators are always full of liquid refrigerants. Okay, level of liquid refrigerant always maintains constant by this. It maintains the constant by float valve. The liquid refrigerant enters the evaporator, and it flows through the float valve or flash chamber and flow down to the tubes. So it flow down to the tubes. Due to the heat transfer, liquid refrigerants boil. So the mixture of vapor and liquid refrigerant collects in a flash chamber. As vapor and liquids are separated in this chamber, due to light and weight, vapor rises to the top of the flash chamber. So vapor rises to the top of the flash chamber. So baffle plates are provided in the tank to prevent the liquid particles present in vapor refrigerant. The vapor is drawn by the compressor. Liquid remains in the evaporator. So the vapor is sent to the compressor, and liquid is remain in the evaporator. So this is a float tube type evaporator works. Here the space to be cooled, and the liquid refrigerant is converted to the vapor refrigerant and sent to the compressor through the buffles. Okay, so as a low density has a low density of vapor lifts up, and high density liquid moves down. So the vapor refrigerant sent to the compressor. Okay, applications of fluoride tube evaporator. It is used in industrial applications, particularly used in food processing and chemical industries. Okay, Funnel tube evaporator. This is the funnel tube evaporator. In the funnel tube there is a number of refrigerant in, refrigerant out, number of fin tubes are there. So layers are layers. One refrigerant is out, refrigerant is out. So in funnel tube refrigerator widely used in air conditioning applications. Fins are provided around the coils to increase the surface area of evaporator. Fins increase rate of heat transfer. It also increase the rate of heat transfer. The funnel tube evaporators usually 4 to 6 fins are provided for each centimeter length. Wide spacing is given between fins to avoid clogging for low temperature applications. Next one is shell and tube evaporator. It consists of steel shell cylindrical in par shape fitted with a number of parallel tubes. It also called chiller. Shell and tube evaporators are floated type shell and tube evaporator, dry expansion type shell and tube evaporator. And first dry expansion type shell and tube evaporator is, see the suction line to the compressor, thermostatic control, liquid refrigerant entry. There is a shell and tube type. Shell, this is the shell we called, and tube evaporator. The fluid chilled to entry and fluid chilled to exit. So the fluid is processed through the surface. Refrigerant flows through the tubes and liquid to be chilled inside the shell. Okay, so refrigerant is flows around the surface of the shell tubes and in the liquid to be chilled inside the shell and in the tubes. So bubble plate increases the overall heat transfer. Buffet plates are provided so that fluid to be chilled moves up and down, finally upwards before leaving the evaporator. Refrigerant extracts the heat from the fluid and gets superheated in the last portion of tube. The refrigerant is collected in the end chamber. From there it is drawn by the compressor. These evaporators used for refrigerating units of 2 to 250 tons capacity. Shell and coil evaporator. Next, shell and coil evaporator. Previously shell and tube. This is the shell and coil type evaporator. So there is a inlet liquid in the inlet liquid and suction outlet in the coil flows in the coil, cooling coil. So water inlet, water outlet, water is flows in the shell type of tank. So it consists of the steel shell in which tube coils are fitted in spiral shaped or fitted. Refrigerant flow through the coils. Shell and coil evaporator. Liquid to be chilled passes through the shell and comes in contact with chilled tubes and gets cooled. It is used for chilling of water for drinking purposes. The cooling water temperature is maintained 5 degrees centigrade and above to avoid freezing problems. Used for plants of capacity of from 2 to 10 tons. So this is used only for capacity of 2 to 10 tons. So maximum it is used in the maximum it is used for chilling of water in the drinking purpose we use it. Okay, this is the next in this class we studied about the functions of what is a evaporator, the functions of evaporator and classifications of evaporator, and then various types of evaporator, different types of evaporator. So the frequently asked questions are there. So in this class the frequently asked questions, see the frequently asked questions. So okay, thank you students.